So this is going to be how to set up the Python um, program for Snake, and we'll look at how to make the GUI in the next video. So here I'm just setting up some Python files. We're going to set up game, main, players, test. Here we're starting in game, and we're just going to go ahead and grab some really standard inputs or imports. And the first thing that we want to do here is just set up some global variables, and each of these is going to represent a possible move that the snake can make. And the goal here is that when we're updating the snake, we just want to be able to do snake.head plus equals move, something like that, and that'll just move the head of the snake. And here, just so that we can access every single move, we're just going to say moves equals, and then this array of all the moves. A few more global variables. We're just going to have an empty that's just going to represent an empty cell, and then we'll have food that's going to be 99. That just represents a piece of the board that has food on it. So next we're going to actually make the game. So that's going to have parameter size, number of snakes. Our hope is to have multiple snakes on the same board at some point that can kind of compete and play against each other. So here we're just going to go ahead and initialize all of the variables that we're passing in, and we'll have GUI is going to start out as none. We will go ahead and change that, I guess, in the next video when we actually make a GUI. We're going to have max turns is going to be just set to 100. You can make that whatever you want for now. And display here is just going to be a flag that's telling us whether or not we're using a GUI or printing out the board. Because when we're training, we wouldn't actually want to be displaying the board every single time. So number of food pellets, that's just going to be num food. We start on turn 0, and we're saying each snake is just going to be of starting length 3. And here what we're doing is just defining each of the snakes. So we're just going to say that it's j plus 1 times size over 2 divided by, divided by 2 times the number of snakes. And what this is going to do is it's going to space out the snakes on the board, but it's going to centrally locate them. So here I is just indexing the size of the snake, and J is going to index the number of snakes. Now the next thing that we need to do is just make a list of tuples that represent the food. So this first tuple here is going to spawn food up in the top left, and then this next tuple here is going to spawn food in the bottom left. This third tuple is going to spawn it in the top right, and then this last tuple will spawn it in the bottom right of the board. Now, the next thing that we want to do is just set up player IDs. This is just going to house the players that we have, and it's going to allow us to remove players that have died, and in doing so, we'll be able to check who is still left alive. So now we're just going to build the board. So self.board is going to be numpy dot zeros of size by size. That just gives you a 2D array of size. And then here we're just initializing each element of the board. So the board is already set to 0, so we don't need to initialize any of the empty ones, but we are going to make it size I plus I plus 1 and then food. And here we're not quite done with the init method yet because we need to actually spawn a list of tuples that we can iterate over that will be the places that the food is going to spawn, right? After we eat a piece of food, we need to then spawn another one. And you could do random spawning, but I think it's better to just generate a random list that you can use for every game. This way, if we play multiple games, if the same agent is training on multiple games, it will get the same list of food each time, and that will be easier for debugging. You could always change this to just be random. You could, instead of copy and pasting this list here, you could have just had self.foodxy equals that random spawn that we just made in test. And then that would give you a new one each time, and you could even potentially seed it if you want. It doesn't necessarily matter. This, to me, just feels easier. So at this point, we're done with init, and we're just going to move on to move, which this is going to house most of the logic of the board, and we're just going to first create a list that's going to house all the moves for each player, and then we just iterate over the player IDs. and we just grab the ith snake, and we get the ith move from the ith player via the function getMove. We just add the ith move to moves, and then we're just saying the new square, this is going to be where the snake is going to move to. So our idea is that the last element of the snake is its head. So that's indexed by -1. And here, again, this is exactly what we wanted, where it's just the head of the snake plus the move. And now we add this new square to the snake. So this is moving the head up, and now what we need to do is update the tail. So if the snake didn't eat, then we need to update the tail. And if the snake did eat, then we don't worry about updating the tail, but we need to remove the food from the actual list of food. So if we didn't eat, if head I is not in self.food, then we need to set the board that's at the last element of the snake to be empty. And then we have to remove that last element of the snake. That way the snake actually like slithers across the board rather than just moving its head each time and consistently growing when it's not eating. And then otherwise we ate, so we just need to do self.food.remove head I, because we know that there's a piece of food there that we just ate. So the next thing that we want to do is check if the snake's head is out of bounds. So each turn, the only thing that moves is the head of the snake. So we don't have to check anything except for the head of the snake each turn. So same thing, we just iterate over all players, and we just check if the head is greater or equal to self.size, it means it's out, or if head is less than 0, it means that it's also out of bounds of the board. So if this is the case, then we just remove the player from player IDs, meaning that it died. Otherwise, we know that it's in bounds, so we're just going to update the board accordingly. So we just set that piece of the board that we just moved to I+1, that's the display of player I. So the next thing that we need to do is check for collisions, because the other way that a snake could die is if it runs into another snake. So again, we just iterate over every single player. We grab the head of the ith player snake, and now we're checking all snakes rather than just the snakes that are alive, because we could end up crashing into the carcass of a dead snake, and we need to check that. So if I equals j, we're checking if we crashed into ourselves. So what we need to do is check if head I is in self.snake up to, but not including the last element, because the head, that would always yield true if the head just crashed into the head. And then otherwise, if it's not the j snake, then we just check if head I is in the j snake. And if it is, then that means that we crashed, so we just remove self.player from, or we just remove that player from player IDs. Now, the next thing we want to do is update any new food that we could have potentially eaten. So all that we're just going to say is, well, there aren't, 4 pieces of food on the board. We're just going to grab the x and the y coordinate of the next food xy from that list that we spawn, and then we need to check if it's empty. So while it's not empty, we'll just continuously generate a new xy coordinate. Now, once we know that we're spawning food onto an empty square, then we'll append x and y to food, and we'll just update board to represent that there's actually food there. And of course, increment the food index. And then we just return the list of moves that each player is going to make, because we're going to need those in play. So the 2 functions that we have left to right are just display board and play. Now, in play, what we want to do is take in display and termination. Termination is just going to be a flag that if the snake doesn't eat for, let's say, 10 turns, something like that, then we just automatically kill the snake. And that'll save us a lot of time with when we're training agents, because we might be training an agent that just spins in circles, and we wouldn't actually want to incentivize something like that. So here we're just going through, and first we display the board, then we do our game loop. So our game loop, we're going to iterate through, or if we're terminating, if termination is true, Then we need to iterate through each snake and make sure that it's eaten recently. And the easiest way to do this is just to check if the length of the snake is at least self.turn divided by some constant, because that means the snake is eating on average about once every, that constant number of turns. If it hasn't happened, then we just remove I from player IDs, and we'll right now we're just going to return -2 because we want to test only on a single snake, but we'll remove that return once we start working with multiple snakes. So the other thing that we need to do is check if the length of player IDs is 0. That means that there's no living players left. There's no living snakes. And then the other thing that we need to check is if turn is greater or equal self.max turns. That means that the game is just over. And then now we'll get moves. That is from our function self.moves, and that's going to be the move for each player. And same thing, if the moves are if the moves are going to be displayed, then we'll display them, right? And that's where the display flag comes in. And here, keep in mind that all the moves are already made in move, so we don't actually have to put them in play. So self.display board, that's just going to print out the board, and then what we want to say is if the GUI is not none, then we'll go ahead and update the GUI, which we'll write the GUI later. For right now, it's just none. So right now we are done with play, and we're just moving on to display board, which is a relatively simple function. All that it's going to do is just iterate over each coordinate of the board and print out essentially what's at that board. So if it's empty, we're just going to print out this, and we make sure that we use end equals the empty string. That way we don't make a new line. Otherwise, if there's food, we're just going to print a hashtag there. And then otherwise, we know that there's a snake at that coordinate. So we're just going to print out the number that corresponds to that snake. And remember, we have to cast it to an int because we used a NumPy array. And same thing, we just end. And then we print out that for the new line. So it's just going to iterate across the board, and it's just going to print out everything that we need. So what we need to do now is just build a player that's actually going to play this game. So what we'll do is just create a random player. We'll make more players later on, especially when we start getting into the AI component of this. But for right now, we'll just have a player that makes random moves. So all that it takes in is just an ID, and then get move. That's that function that's used in move of game. And we're just going to generate a random int between 0 and 3 inclusive, and that's just going to select a move for us because there's 4 possible moves. So now we're just going to set up a really quick test just to make sure that everything's working, and if I wrote everything correctly, it should just work. So we just go ahead and copy paste all of the parameters that we want, and then we'll just go ahead and build them. So now we just want to do game.play. Game.play should take in 2 arguments, I think. Yeah, it should be display and termination. So we'll just say termination equals false because I'm pretty sure this random player is just going to kill itself. And it happened. The random player just, it looks like at the last turn, it literally just turned around into itself and died. I also want to add a sleep time just so that we can see the moves happen in real time rather than all of them just happening at once. So I'm just going to run this. Yeah, okay, there we go. So we just saw we have a snake that went through.